This hard drive is faulty, so we're going to strip it down and have a look at the internals. When you pull a hard drive apart, you can't put it back together unless you've disassembled it in a clean room. The insides are very sensitive to dust, and you definitely don't want to be pulling one of these apart if it's got data on it that you need to salvage. The exception to that would be if you're using a clean room and you've got a similar drive and you hope to swap components in order to repair the existing drive. But as I said, you want to do that in a clean room. So what we're doing here is removing the top screws. You'll find there are Torx of some size. I can't remember what size this one is, but you'll need your Torx screwdriver kit. I can't remember what the specific problem with this drive was. Some kind of read error, I think. Oh yeah, I've got C5 written on it. I forget what that is, but you can look that up in hardware info or crystal disk. Some of the screws are hidden under labels, as you notice there. I think I've still got one to come off. That's why I can't pull it. There's one or two. Sometimes you can break through the label, or sometimes you have to peel the label to find the exact location. There we go. Okay, there's one more. Now if you're pulling this apart with a view to reassembling it in working order, you obviously be a lot more careful locating all the screws that need to be removed, as you wouldn't want to be putting any bend or flex on that top plate, that cover, as you could disturb the seal. I'm just looking there because I wasn't sure where the other screw hole might be. I was wondering if it was being held down from below, which is not normally the case. So go back to the top to have another look. If you've got a particular drive and you're trying to remove it without doing too much damage, then you can try Googling or YouTubing the model number and the word teardown, and you'll often find someone else who's pulled that same model drive apart or a similar model. There's the internals. You've got the platter, very, very reflective. Although that surface, although it looks very smooth and has a mirror finish, is actually purposefully rough. If it's too smooth, then the head won't fly across the surface properly. The head doesn't actually touch a surface, it rests on a bed of air. So if the surface is too smooth, that airfoil doesn't work right, and the head will just bounce up and down on the surface of the disc. And if the head touches the disc, it damages it. And that air gap that the head floats on above the surface of the disc is so fine that even a particle of smoke can get jammed in between there and do damage. So that's why your hard drives are sealed, and that's why even if you open one, it may look perfectly clean, you could have a bit of smoke in there, a bit of vapor of some kind of particulate that could later cause damage. So that's why I use a clean room, which is a room with a negative or other positive air pressure. So in other words, the air is pushing out of the room, not in. So any material, dust, etc., gets pushed out and doesn't get sucked into the room. And of course, you use masks and gloves and things. So we look around here, and we've got the platters obviously, and we've got the head there, the armature, the head that has the reed heads, the arm that has the reed heads. Here I'm removing the first magnet. Now these neodymium magnets are quite strong and very useful for other projects. Great little magnets, one of the best spare parts you can pull out of a hard drive. And in fact, not so bad with the little drives like this, but a 3.5-inch drive, you want to be careful when handling the two magnets. There's two in there, the other one underneath the arm. When you're handling those, they can snap together quite powerfully and pinch your skin on your fingers, so you definitely want to watch that. That should just fall out. It's not for some reason, something's still holding it. Possibly just the disc platter. We'll have a closer look at that arm when we get it out. You can see the windings on the back of the arm, copper windings. That's what helps it. It helps move it backwards and forwards across the surface of the disc. And that's what the permanent magnets are also for. It's like basically the same principle as a motor. It drives the arm backwards and forwards. And what we're looking at there is the connector that routes the data from the disk out onto the circuit board on the back of the drive. That one simple little cable carries it all. All the data from the heads. There's actually surprisingly little electronics on the inside of the drive itself. Okay, let's get the platters off. So this drive has two platters and four heads, four reed heads, one for each side of each platter. The platters are made of glass. They used to be made of aluminium and other materials, but they're made of coated glass, coated with a magnetic material, obviously, in order to store data. As you can see, they're quite shiny, but they're also major fingerprint magnets. So that's just a spacer ring to keep the two discs separate. Okay, I'll drop it out. Now this is a little filter. It's not for outside air. No air really can get into the drive. This is for recirculating. It's a recirculating air filter. And the drive does have a vent hole with a filter. But that filter there is for anything that any bits of dust or whatever that get broken off the internal components in the normal wear and tear gets trapped in that filter. Helps the drive last longer. Due to the discs, the platters being so smooth, at least to our sensors, they can be quite sticky to each other. And as I said before, magnet for fingerprints. Once you've touched those and handled those, you'll never get them clean. If you are disassembling a drive, you need to be using gloves and appropriate handling tools, and you would only ever touch the outsides of that disc. And there's the second magnet. Bang. As you can see, they're pretty strong little magnets for their size. Pivots on that bearing. And that's the bearing and motor for the hard drive, for the platters. I didn't end up removing the motor spindle because it's quite firmly pressed in place, and I didn't feel like trying to prise that off this time. So now we're removing the main board from the back of the drive. Sometimes if you have a problem with your hard drive, a read error of some kind, it can just be this board. And if you have an equivalent hard drive, same model, same size, you can try swapping the boards. It's a relatively easy procedure, and you don't need to be pulling the drive apart internally in order to do that. You can literally just undo these Torx screws, lift the board off and replace it with another same board. It has to be the same model in general. It'd be very rare that you could pull a board off another model drive, even though it appears to fit. It likely won't be compatible because the firmware in the controller won't match. Sometimes you might be able to read the drive, some content of the drive, but you could have problems copying the data, or it could just be unreadable. If you do swap a board from another drive, make sure you replace that insulator there, that little foam piece. To remove the motor spindle, you'd hammer that centerpiece out. It's a push fit, very tight push fit. You could hammer that out and pop the motor that way. So inside that spindle, obviously, is electric windings for basically it's a motor. And here I'm just investigating these little covers here, and I'm not sure what the point of those is. I'm not sure if that's a light, if they're red, translucent red covers, and I don't think they're a valve like for airflow. They might be, but the other possibility might be for calibrating the drive. Once it's assembled, you shine a laser or light through those holes in order to calibrate the drive. But I'm just guessing about that. I'm really not sure what those two holes are for. The actual filtered vent for the drive is in the top aluminium plate. Okay, here we have the heads. So as you can see, there's four. There's those four little springy claws, and on the tip of each one is a head on the inside. Between the two in each pair, the heads are on the inside, and the platter fits between those two heads, which, due to magnetic forces, never actually touch the head, and also airflow. Okay, now we're going to have a look at the surface of the disc. This was quite difficult to film. I could have another go at it, but I figure we can see it, so I left as is. But the surface is very, very hard. The surface coating is very hard. As you can see, I tried to scratch it with the screwdriver, and I did succeed, but it's not a very deep scratch. Doesn't go through to the glass. And finally you do eventually get to actually see the scratch in the surface. But as you can see, it's very hard. And these platters are made of glass. So now what you're going to see, I'm going to break the platters and you'll see how they shatter into pieces. Once upon a time these used to be made, and sometimes still are, of aluminium or other materials, other metals, and you couldn't break them, like couldn't shatter them like this. You had to, you could bend them, you could hammer them and bend them, but they were very, very hard. You can see here, it's definitely glass. And next up, you'll see one with the sound included, so you can get an idea of the sound they make when they snap.